All right, so there's different problems that you're going to see. First, the first one is what I already explained to you. All right, here are the two steps. Step one always is find the greatest common factor and factor it out of the parentheses. Step two, you break apart the first and the last term. That's it. No work required here. There's no calculating here. This is straight to the answer. So let's use this as an example. Between 9 and 25, there is no common factor. So we can skip step one and go straight to step two. Step two, break apart the first and the last number. So remember, these are difference of two perfect squares. So all you do is two parentheses and break down the first and last number. What times what is 9x squared? 3x times 3x. Now break apart the last number. 25 is what times what? 5 times 5. So you put a 5 on each side. And now just make sure the signs are different. Plus, minus, and you're done. Any questions? This is difference of squares. Not new. You did it last time. Now, on the next page, I want you to try these two questions on your own. It's going to be just like this. Run through your two steps and try this on your own. So, on the green question, on number one, let me remind you how to find a common factor between two numbers. Do a little T-chart. Put both numbers on the T-chart. So 18 on one side, 50 on the other. You're only breaking down the small number. So 18 is 18 times 1, 9 times 2, and 6 times 3. Our job is only to figure out which one matches with 50, which one goes into 50. Obviously, start with the biggest number first. 18 does not work out because it can never give you 50. 9 can never give you 50. 6 can never give you 50. And 3 can never give you 50. So what's the only number that they're both divisible by? 2. Aren't they both even numbers? All even numbers are divisible by 2. So all you do is put a 2 and open your parentheses. Now, divide and write the results on top. 18x squared divided by 2 is 9x squared. And negative 50 divided by 2 is negative 25. Now, what we have in the parentheses is a difference of squares. So we're ready to put the answer already. What's the perfect square for 9x to the second power? 3x. What's the perfect square for 25? 5. So you put a 5 on each side. Now make sure the signs are different. Now what am I forgetting on my answer here? Look at my square. What am I forgetting? The number 2. Never forget to bring down whatever you took out at the end. Simple? Any questions? Let's try the next one. 98 and 2. What are they both divisible by? 2. Now write down the results in there. What we have left here is 49x squared minus 1. Now here in the parentheses, difference means minus. Of squares means that those two are perfect squares. They are perfect squares. What number multiplied by itself gives you 49? 7. So we put 7x on one side, 7x on the other. Now, what numbers multiplied by themselves give you 1? 1 times 1. So you put a 1 on both sides. And now the signs always have to be different. So you put a plus and a minus. And don't forget to bring down the 2 that you factored out at the beginning. Simple? Any questions on that? So this is like the basic one, the one you've already seen me do. The next two sets of examples or it's going to be new to you, but you're not going to do it differently. You're still breaking apart the first and last number just like we do here. Give you another couple seconds and we'll move on. All right, let's go to the next page. On the next page, this is another style of question you're going to see here. Let me change that to a 3. So we have 9x to the third power minus 16x. Now, first of all, between 9 and 16, do they have a common factor? No, because 9 can't give you 16. And what else gives you 9? 3 times 3. Can 3 give you 16? No, it can't. So we know that they don't have a number in common, but they do have something in common. What do they have in common? They both have at least what? 1x. They both have at least 1x. So you can factor out the x and write what's left in there. 9x to the second power minus 4. Minus 16. I don't know why I put 4 there. Minus 16. And now look at your parentheses. What's in the parentheses is the difference of two perfect squares. So we're ready to put the answer. Two parentheses. Now break apart that first number. What times what is 9x squared? 3x times 3x. What times what is 16? 4 times 4. So you put a 4 on both sides and make sure the signs are different. Done. So I want you to follow those same exact steps that we took on that blue question and follow the same steps for the pink and the gray question, number 1 and 2. So on the pink question, between 8 and 50, they're both even numbers. That means they're both at least divisible by 2. So we know they each have at least a 2 as a factor, but they each have an x as well. So you have to factor out a 2 and an x because that's what the two terms have in common. Now, divide to figure out what's left in your parentheses. So if we divide, we get 4x squared minus 25. Now we're ready to put our answer. Put two parentheses. Don't forget to bring down your 2x next to it. Now let's write our answer right here. Break down the first and the last number. The first number is 4x squared, which is 2x times 2x. "25" is 5 times 5. So we're going to put a 5 on both sides. And now, difference of squares have different signs, so you just make the signs different. Now, before I continue, what are the three factors? Before I continue, what are the three factors that we put on our answer right here? I put a box over it. Tell me what the three factors are. Here's a hint. Factors are things that are being multiplied. What's being multiplied on your answer? 2x is 1. Very good. Next. You're missing some stuff there. Anybody else? What is 2x being multiplied to? 2x plus 5. It says it there. 2 times 2x plus 5. Times what? 2x minus 5. So I want you to understand what the factors mean. What are factors? Factors are just the things that are being multiplied. Clear? All right, now let's do the last example here. So between 8 and 200, 8 is 8 times 1 and 4 times 2. You have to try the biggest number here first. 8 actually does go into 200. So they both have an 8 and an x as a common factor. Now let's see what's left in there. X to the second power minus 25. Now what's in our parentheses is the difference of squares. So we're ready to put the answer. X to the second power is x times x. So you put an x on both sides. 25 is 5 times 5. So you put a 5 on both sides. And the signs have to be different. It's pretty simple, guys. It's pretty simple. No work really required. All you have to do is factor. Copy it down, and then we'll do the last two examples. Between 2 and 162, the common factor is 2. So what's left in the parentheses is x to the fourth power minus 81. Now we do the same thing we've been doing throughout this entire lesson. You break down the first and the last number. So x to the fourth breaks down to x to the second times x to the second. 81 breaks down to 9 times 9, and the signs have to be different. So now you're doing number 1 and 2 on your own, and I will review it after. All right, let's review the last two questions. After that, you can get started on the classwork. So pay attention so that you all understand this. On number 1, the leading coefficient, the number in the front, is a 1. When the number's a 1, you don't have to do a greatest common factor like we did here, because there is no common factor. So we can go straight to the variables. Do they have a variable in common? No, they don't. That's an x, that's a y. So that means there's no factoring out. I'm ready to put my answer already. Two parentheses, break down the first and last number. X to the fourth can be broken down to x to the second times x to the second. Now go to the last number. 81 y to the fourth is 9y to the second times 9y to the second. And now make sure the signs are different. So far, so good. All right, last example, this green one over here. So between 4 and 25, there is no common factor between them. X4, Y4, no common variables between them. So we can already get to the answer. Two binomials, break down the first and last number. 4x to the fourth power is 2x squared times 2x squared. Now break down the last one. 25y to the fourth would be 5y to the second times 5y to the second. And now make sure the signs are different. So far, so good. Any questions on that? So let me show you what the worksheet looks like first, and show you on the screen some that might be confusing for you. So pay attention really quick so you don't have to skip any of these questions. First of all, look at number 10. The only difference between what we've been doing and what you see on number 10 is that they wrote the numbers backwards. So you can just write it the normal way, a to the fourth minus 81. And now you know how to do it because it's in the same setup as you did in your classwork or your notes. That's one, right? The other one that was confusing for students, give me a second. Right here. Look at number 13. Now, off the bat, is 4 a perfect square? Yes. Is 100 a perfect square? Yes. Now, here's where people make a mistake. They think that right here you can already put the answer. What did I skip right there? I skipped GCF, greatest common factor. 4 and 100, don't they have a common factor? So make sure you take out a 4 there, because 4 and 100 are divisible by 4. Then you can do it the normal way like we've been practicing. Okay? This is the worksheet. I'm going to post it on Google Classroom in a second. I'll tell you when to refresh. Those of you that are here, no need for that. I'm going to give you a worksheet. Boys first. I'll bring yours now, Anthony.